The diagram opposite represents a drive belt, A, B, C, D in a large machine. A, B, C, D. It is wound tightly around two discs so that the sections AB and CD are tangents to the two discs. So AB and CD. So AB is a tangent to the disc or the circle on the right, which means it touches it at one point only. There's only one point of contact. And likewise, the point A is the point of contact for the larger circle or the larger disc. Point C is the point of contact for the smaller disc. And point D is the point of contact for the larger disc. So they're tangents, they only touch the circles once. The structure is supported by a rod PQ, so PQ, joining the two centres and two other rods, QX and QY. So QX and QY, such that XQ is parallel to AB. So XQ is parallel to AB, and YQ is parallel to DC. So YQ is parallel to DC. Part 1, explain why ABQX is a rectangle. So ABQX, explain why this is a rectangle. Part 2, explain why the triangle PQX, so PQX, and PQY, PQY are congruent. And part 3, prove that the distance from A to B, or the length of AB, is equal to the length of DC. So part 1, explain why ABQX is a rectangle. So ABQX, why is this a rectangle? Okay, so as AB is a tangent to both circles, so AB in blue is a tangent to the smaller disc and the larger disc or circle. AB is perpendicular to AX. So AB is perpendicular to AX. They meet at right angles, 90-degree angles. And AB is perpendicular to BQ. So AB is perpendicular to BQ. Again, they meet at right angles, 90-degree angles. And that is because a tangent is always perpendicular to a radius. So PA is the radius of the larger disc, and XA is a section of that line. So if PA meets AB at a right angle, then XA also does. And likewise for the smaller disc. Hence, AX is parallel to BQ. So AX must be parallel to BQ because these are both right angles. These are both 90-degree angles. As XQ is parallel to AB, so XQ in green is parallel to AB in blue, and that was given to us in the question. ABQX is a parallelogram whose adjacent sides are perpendicular. So XQ is parallel to AB, given in the question, and XA is parallel to QB, which we worked out because of the tangents. So since all sides are parallel to the opposite sides, and also the angle here and here are 90 degrees, then obviously the other angles must also be 90 degrees. Thus, ABXQ is a rectangle. Part 2. Explain why the triangle PQX, so PQX, and PQY, so PQY, are congruent. Remember, congruent triangles are identical. They have 3 equal sides and 3 equal angles. Okay, so consider the triangles PQX and PQY. So we're going to start with the length PX, so that's drawn in green. So that's equal to PA minus XA. So PA is the full radius, minus XA is one end of the rectangle, leaves us with PX. Now XA is also equal to QB. XA is equal to QB. and that was from part 1. So PA minus XA is the same thing as PA minus QB, which is also the same thing as PD minus QC. So PD goes from the centre of the circle up to D, and QC is from point Q up to C in blue. So they are equal radii. So PA goes from the centre of the circle down to A, and PD goes from the centre of the circle up to D. So they are equal radii. So therefore, PX in green is equal to PY in orange. So PX is equal to PY. Also, the angle PXQ, so PXQ, so this right angle here, is equal to the angle PYQ. So PYQ, this right angle here, so they're both equal to 90 degrees. And we know that because we know that this angle here is definitely 90 degrees because it's a tangent to a radius. And since AB is parallel to XQ, this angle must also be 90 degrees. And likewise for this angle here. And we know that the length PQ is equal to PQ because they are a common side, they're the same thing. So thus the triangles PQX and PQY are congruent because of RHS. So they both have a right angle. Both their hypotenuses are the same. So XQ is equal to YQ. And they also have an extra side that's the same. PX is equal to YP. So since we've proven RHS, we know that the two triangles are congruent. Remember, other ways that we can show congruency is ASA, angle side angle, SAS, side angle side, and SSS, side side side. Part 3, prove that AB is equal to DC. So AB in yellow is equal to DC in blue. So as the triangles PQX and PQY are congruent, we worked that out from part 2, we know that QX is equal to QY. So QX in pink is equal to QY in green. So they're the hypotenuses from the right angle triangles. And we also knew that from part 1 because we worked out that we had two rectangles. Okay, as ABQX and CDYQ are rectangles, so ABQX, and CDYQ, CDYQ, as they're both rectangles, AB must also be equal to DC. So AB is equal to DC. And that's what we were asked to prove.